Hello, everyone. Welcome to this webinar on water quality modeling with 3DI. My name is Jonas van Landman, and I'm the product manager of 3DI. Next to me is Rutger Wiebing. Maybe, Rutger, you can shortly introduce yourself.
Thank you, Jonas. I'm a consultant at Nederlands Schuurmans. I model a lot with 3DI and also recently with water quality. So I will give the demo on how to use water quality within the model interface.
All right, thank you. First of all, I'll keep it very short. We have a few participants in watching that are not that familiar with 3DI yet. I'm doing 1 or 2 slides on 3DI and then we'll dive into the water quality. So first of all, what is 3DI? Hydrodynamic simulations, interactive and online, and you can apply it for flood risk management, urban planning, drainage design, and integrated water management. If you like to know more about 3DI and how it works, and something, for example, about the computational core and what we do, you can book a product demonstration on the website, or you can also just request a free trial and try it out yourself. That is, of course, the free trial is including the water quality that we are about to show you. So the water quality, what we see is that there are increasing issues with water quality. There is also more and more attention for it from governments and the public that are interested in getting to know the water quality and how to improve that in their living area. And we have, with 3DI, decided that we also would like to add the water quality to the simulations and help users get more insight into water quality. But first of all, to be able to say something about water quality, you need to know how the water actually flows. So with 3DI, we have adopted this approach that we follow every drop of water above and underground. So you can model rivers, you can model sewage system, you can model the groundwater tables. So these insights and these water flows, these are the basics that you use for your water quality modeling. So basically what we are saying is, for insights in the water flows, the insight in the water flows is the basic, the base on which, the foundation on which you do your water quality simulations. So recently, for example, we have adopted also the 2D flow that you can see here in a animation from 3DI Live. And we have recently released the first batch of features where you can use your 3DI model for water quality calculations. And then, of course, the question is, what does it do? And we have basically 2 types of simulations that we can do. The first one is substance dispersion, including decay. And the second one is that you can label the origin of water. And you can track these throughout your simulation. And this gives you insight into the spatial spread of a substance, the spatial spread of labeled water, and also, in the end, the residence time of water. So how does that work? For substance dispersion, what we see here is an animated GIF. I use the modeler interface to generate that. Rutger will also show you how you get these images in the modeler interface. Building a GIF out of it is actually not that difficult anymore. First of all, you define a substance, a unit of measure, and a decay factor. And then you can just track this substance through all your domains in the model. So in this case, we have a river, including the bathymetry, a small part of the River Rhine that we're looking at. But we can also include more complex situations. So, for example, you have a sewage network, like here. There's a spill in the middle of the road. For example, here on the crossing, the red circle, a tank truck has spilled a load of chlorine, and then it starts to rain. Okay, what does happen? And in the simulation, we can see that the spread of chlorine is over land and also through the sewage system. Here you can see here the coloring in the sewer system going up. So you see the concentration going up in the sewer system, but you can also see the squared. You can see the substance spreading over land. So dark blue means low concentration, green is sort of middle, and yellow is a higher concentration. So the other thing that we do next to substance dispersion is the assigning a water a label. So you can do that based either on a location, for example, initial water that is in your system already, or where precipitation occurs, or you assign a label to a special inflow type like dry weather flow. And then you can see basically how that is spreading to your system. So here on the right hand side, you see an animation of, in this case, overflow of a weir of the sewer system, and how that actually spreads through the water system. And you can, of course, also, this is a mock-up, but you can then click downstream and you can see the composition of either the water, so the label that you gave to the area that the rain was falling on, or the composition of the substance from which area they are coming, of which location actually it is coming. You can see that downstream. So these are basically the options that you have. And this gives you a lot of options, not only for water quality, but also it enhances greatly the insights that you have in how the flow in your water system actually works. So that can either be it for a river, or that you have multiple watersheds coming together, and then you see which watershed contributes the most to the peak of the flood, for example, but also in the sewage system network, from which area actually the water is coming that is causing a flood. And coming soon, of course, is that if we can label the inflow, so we can have a percentage of dry weather flow on the street, we can also show how dirty is the water on the street. So basically, be it completely clean, as in, let's pretend rain is completely clean, compared to where the water is actually coming out of your, for example, combined sewer, and then it's going up, and then you have a percentage of dry weather flow on the streets. This is a mock-up. This is coming soon, and this will also enable those extra insights that you want to have in your urban water system. And well, when we are doing all this, then sort of what we also can include at the end of this year is the residence time. This is an example. Again, this is also a mock-up. This is under construction at the moment, and then we can calculate the residence time of water in a water course, and this will give you insight. For example, if you have issues with water quality and you are modeling it, you can use this as input to know how long the water is standing somewhere, and that's a really big indicator for potential water quality issues. So how does it work? Well, it is very easy to set up. Basically, you use the exact same model that you used for your water quantity calculation, and that's it. The workflow is that you add, for example, a source location, a point source location in your schematization. You run your simulation, and then you can analyze using the results analysis tools to see how these substances spread through the water system. So I think it is time for the demo. Rutger, can you maybe take over the screen?
Yes,
if you click on share, then you can share your screen, and I think it should automatically take over from me. Floor is yours.
Yeah, so thank you. I will now demonstrate, as Jonas said, how easy it is to use it in a model that you already have. So I have a little demo model here, and I will show you how to use water quality within this model. So it's a little model with some 1D elements and some 2D digital elevation model. what I'm going to do is set some laterals on the inflow points of the houses, add a substance concentration to it, and then run a simulation with so the 1D laterals and some precipitation, and we will see what will happen. So this is how you just use to simulate your model. You log in as a user, you put in your schematization, and you just click on simulate. So I will get a new simulation, second revision. And now what's new is that here there is a include substances box that you can check. So well, now in this simulation template I've already checked it. So I want to include substances, I want to include the boundary conditions, laterals, groundwater flow, not for this case, and include some precipitation in this simulation. So then we go to fill in simulation template. So I have here, you can name it. So I've named it demo water quality on the lateral. Yeah, you can choose it yourself, of course. Make a simulation duration. So I've now put in a small event from 1.5 hours with some rain added. I will add that later. And now this is the new part. So we have a new part that says substances, and here you can define your substances. So in theory, you can add as many as you want, and you can name them as you like. So for now, I will include 2 substances, which will be phosphorus and nitrogen. 1, 2 substances. Then you have to define the unit, and you can define it yourself. So, but while you can define it yourself, it's important that it is in accordance with your input files. So I'm going to show the input files a little later on, but I've made my input files in milligrams per liter, so I will also set the unit is milligrams per liter here. And then you have to fill in a decay coefficient for each substance that you define. While this is a very limited simulation time, I will add a decay coefficient of 0. But this decay coefficient determines how fast your substance will decay over time. So what you actually do is you take open fraction of the substance every time step. But for now it's 0, so it won't do that, but it is possible. And now this is new. If you define the substances, you can also upload CSV files with substance concentrations on, for example, the boundary conditions, but also on the initial conditions, the laterals, and it is under construction, but also to the precipitation. So for the initial conditions, in this model, I have defined a initial water level on this pond here. So that you can see, this is my initial water level raster. And now here, when I scroll down, I can also upload the rasters for a substance, which will then be applied to the initial water that is present. So I've already made 2 concentration files, and I will add this to the simulation. I will show it when the simulation is finished. Then for now I have to upload the laterals, the 1D laterals, and this is just how you used to do it. So I have here a lateral file with, in this case, a very simple 1D lateral. So it will, from 0 to 60 minutes, it will disperse a discharge of 0.0077 cubic meters per second. It will do that on this connection node that I filled in here, and with a unique ID for the lateral. So this is just how how it's used to be done. But now the new thing is, if I upload this lateral discharge, the new thing is I can also upload a substance concentration, which is then added to the lateral. So how does this file look? It is also a CSV file, and now here there's ID and time series. So here you can fill in any time series you like, just as with the lateral CSV. But you see here that I have put it in a number of 9, and while I have defined my unit for the substances in milligrams per liter, this says 9 milligrams per liter. So from 0 to 60 minutes, it will add 9 milligrams per liter to the lateral with ID 313661. So I upload this CSV also to the substance concentrations. Yeah, so now there's also laterals added with a certain concentration, which is put into that. For now, I've also input a fairly simple precipitation event from 10 millimeters per hour for 1 hour, and then it stops. Later on, you can also add substances to the precipitation to label your precipitation, but that is not yet in the model interface, but will be coming soon. And after numerical settings, and I can just start the simulation. So now I go to the live site really quick. And I can follow this session. You see this is a fairly quick model, but we see it flowing in the 1D system, some on the 2D elevation model. And here there's an overflow which spills mixed sewage over into a pond. And it's finished, so we can go back to our QGIS, download the results. And then we load in the results with a result plugin. That is also how you used to do it. So, well, now when I want to add a simulation result, you see that you have 3 result files. So we have the aggregate results, we have the normal results, and we have the water quality results file. Well, you don't have to load the water quality results file in separately. You just load in the results, and it automatically in the background also gets your water quality results in. So I will load the results, and now you see the computational grid. It's a fairly fine grid. And when you put here on the I symbol, you visualize your results. So for now, I will show the discharge lines. But you see now it will show the water level. Well, now here in the results manager, you can also now click on the node variable and change from this water level not only to the all the parameters that you're used to we're able to click on, but also now the nitrogen and phosphorus, the substances that we defined in the simulation template. So now I want to show you the phosphorus. So I click on the phosphorus. This will show the phosphorus concentration. I will exclude all the values that are 0. So now you see in the pond I have defined a initial concentration raster. So there the concentration will be 0.1 because it was on the raster. So the initial water in the pond has already a little bit of phosphorus in it. You also can see here the 1D calculation nodes. So those are 0 now, but you can also track it through the 1D system through the nodes. Yeah, and just like how you used to do it with, for example, the discharge of the water level, you can click play on the temporal controller and it will play your simulation result. But now you see the phosphorus. So you see here on the 1D laterals, there's a concentration added. You see it spreading through to the overflow. Now this overflow starts working, and you see that there's a large concentration of phosphorus put into the pond. So, well, because this is a mixed sewage overflow, it's quite, let's say, dirty water, so with lots of phosphorus in it. So this will overflow into the pond. And you can now see what the concentration is within your system, where it spreads to. And also, I want to show you one last thing. So this is the standard style that it's presented in. But you can, for example, also load another style that you want to show as a client, for example. So I've pre-made this style, but I've made a style from the critical phosphorus value of 0.5 milligrams per liter. So for this pond, for example, there's the critical value is 0.5, so it shouldn't be above 0.5 milligrams per liter. So as you can see now, the default style is changed to red if it's above 0.5 milligrams per liter, and green if it's below 0.5 milligrams per liter. Then last thing I have to do is get here the results, demo water quality 1D lateral. I click this, apply, and now the style has changed. So for example, now you see, because I've had an initial water substance concentration of 0.1, you see that the pond is green because it's below the critical value. But as soon as I start the simulation and it starts to overflow, you will see that there's a too high concentration of phosphorus coming into the pond, so it will be red. So this is quite a nice insight that you can give to, for example, clients or to your own organization. Yeah, so this is how, yeah, let's say convenient it is to use 3DI water quality within the modeler interface.
Correct.
Yeah, for now this was the demo.
Thank you very much. Just one quick question. I mean, in the demo, can you also click maybe on one of the points, for example, in the lake or in the nodes, to show the graph tool and see how that works?
Yes, that is possible. So I can indeed also click on a node, and now you can, for example, see the water level within the pond. But yeah, like the same as here, the node variable, you can also change the node variable here. So this will also, you can also click on the phosphorus, and it will show yeah, the concentration within this point here. So this is quite close to the overflow. So you see that there's a large concentration of almost 9 of the input concentration. Yeah, this concentration will happen at this node. So this is to make the graphs. It's also a nice tool.
All right. Thank you. Let me go back to my screen. Sure. Yeah, thank you. All right. First of all, I forgot to mention at the beginning of the webinar, but there is a Q&A in the settings enabled, so you can ask questions. So if you have any questions at this point, you can already start typing, and we will have time at the end of the webinar to answer your questions if you have any at this point. Here it goes. Okay, so as mentioned already, the results, they are stored in a separate netcdf file. This is especially, Rutger already showed that, especially useful if you are, for example, scripting on 3DI, then you need to use this netcdf. There is also a flow summary available, currently in JSON format, but it will also be available in the modeler interface using the flow summary tool. You can see it sort of like in a human readable way. And as shown, you analyze the results using the 3DI results manager, but note that the substance is available as a node variable. So the substance is always in the nodes and not on the flow lines. And another one that is good to realize is that we are storing the results on a calculation cell level, and they're not interpolated to pixels, as for example is being done with water depth. We are looking into that, but you have to realize that, of course, we are taking the flows into account, as is common with subgrid, how we do it with subgrid, with the profiles from one cell to another. And that we store the results also on that level, and that is the most accurate with the computation that calculation that you are doing at that time. So you might have noticed that where is my no that that Rutger had made the computational grid really refined on that pond that the water was going into. Well, you could, of course, also, if it goes into a river, doesn't matter. You want to have like a high resolution computational grid. Water quality is affected at different scales than hydrodynamics alone. So if you're using this, you should be aware of that, and you should check your model assumptions, like time steps that you're using and the grid resolution that you are using. So if, for example, if you're using a coarse grid resolution, it could mean that you are all right when it comes to hydrodynamic computations, but that you might be missing out on the substance flow, substance dispersion in your computation. So in short, what we are offering here with 3DI water quality is that we combine robust water quantity analysis with water quality calculations with the strengths of 3DI, like subgrid, integrality, and the user-friendliness of our model interface, and that it gives you direct insights in spatial distribution, dilution, and resonance times. And we believe that this is a solid basis, a solid foundation for further biochemical and ecological analysis. So yeah, that is basically in short what we wanted to share with you. Let me stop sharing my screen, see if there is any question at this point in the Q&A. First question is there an overview of decay periods for certain substances somewhere? That is a good question. Rutger, do you have?
Well, there is not a like a general overview yet, because it is also like system dependent. Because, for example, how many is taken up by plants, for example, would be a factor to take into account. So we don't have a general overview yet, but yeah, maybe in the future, because we are working with it a lot more recent. So maybe that will be included, but it's not yet within 3DI. It's not yet present. But there is on the internet, there's a lot of information about differences and like general decay periods.
All right, I see also another question about decay periods. How is the decay coefficient applied? Is that per time step? And if yes, does that imply that a decay rate of 0.5 means that every time step the concentration halves? Okay, I have a slide prepared on decay coefficient, so maybe this is the moment to discuss that, since there are already 2 questions on it. Let me start by sharing my screen again. So first of all, the decay coefficient is described, of course, on the documentation on docs.3di.live. And the formula that we are using is that the decay coefficient here described as mu. I'm not sure how you say it in English. Mu. It's a Greek coefficient, is logarithmic 2 divided by the half-life. So for example, if you have a half-life of 30 days, then the decay coefficient that you just put into your simulation is 2.76 times 10 to the -7. So it is not per computational time step, but it is compared to your simulation time step. how we use it. So I hope that answers the question. I can't really share my screen and check the questions and answers, so I'm going back to the questions and answers. I have a question, Rutger, about the inflow. How did you do it now? Because we cannot label the inflow yet directly. You did it a bit differently, right?
Yeah, well, like now I did it with 1D laterals placed on the mixed sewage system, let's say. So on the calculation of the mixed sewage system where normally the buildings, the rain that falls on the roof of the building will be inputted. So now I did it in this way because it's not yet possible to label all the inflow from the buildings. But in very short notice, that will be available. They are working on it now, so that will be available, within, I think, 2 months at maximum.
It's planned for the end of this year, so depends a bit on whether we release it just before Christmas or after Christmas. We usually don't do releases just before Christmas, so it depends. It depends a bit. But we will be notifying everyone, of course, using the usual channels, the release mails, and of course also using LinkedIn. And if you if you're not receiving that and you are currently a 3DI user, please reach out to us after the webinar, and we will have a look into that, because everyone should be receiving these information. So I have a follow-up question. The 1D lateral inflow is directed to a connection node in the CSV file and not in the spatial lights. Rutger, do you want to?
Yes. Well, in this instance, it was indeed, but you can also add it to. Well, you can add the 1D lateral to the schematization. So, and then you have, also have to input an ID to that 1D lateral. Then when you define the substances, you have to match that ID of that 1D lateral to the ID that you put into the substance, so that it's so that it will add that substance to the 1D lateral that is in your schematization. So that is also possible.
And the reason you did it like this is because I guess it's easier to generate two Excels using the same ideas.
Yeah, exactly. For this showcase, it's easy because now we can do it in the simulation templates, both.
Yeah. Okay. Let me check. All right. If there are no other questions, then I would like to thank you all for your attention. We will be doing a follow-up webinar as well once we have the origin of water included in 3DI as well. We will be sharing the recording with everyone that registered. It will be available online, I guess, somewhere next week. So you will be able to look back into what we have just told you, and also share it perhaps with colleagues or others that might be interested in using this module. Last to say is that we have at this moment, with the module is available free of charge. Starting March the 1st, it will be a paid module in 3DI. And it will be approximately €6,000 a year that it will cost. So that's it. Thank you all for your attention. And if you have any questions or you would like to discuss with me how this can work for you or your organization or in your consulting work, then feel free to reach out. I'd be happy to help you along. Thank you all. Bye-bye.